Hi class. So this is my resonance video. In addition to the swing video, which I might have already shown you, I wanted to record this in my office just in case I work from home for the rest of the day because I have some equipment that's in my office that I wanted to use. What do I have? So I have this vibration generator, which I bought a long time ago, that hooks up to the computer here. This is my really old 15-year-old MacBook. It's really old. And I'm going to be sending some sound into this. And I want to demonstrate what happens when you hit the resonant frequency in a very classic experiment called the Chladni plate experiment. What this is basically a speaker. I have it hooked up to the microphone, the headphone jack here. And to demonstrate that, you can play music through it. I'm not sure if this is going to be picked up. Okay. I don't know if you can tell what song that is. All right, so that's a song that's being played. I'm not going to play a song. I'm going to play a few different frequencies. This is basically our mass spring system, which can be described by a differential equation. The real differential equation is the wave equation, which is learned about in Math 326 if you want to take that. But it can be approximated by a mass spring system. And the forcing function is the sound coming in. So we're going to try different frequencies and see what happens to this plate as we change the frequency and pass through the resonant frequency. Let's see. Here we go. This is some cream of rice that expired July 15th, 2016. If you want to see that. Okay. So I'm going to put some cream of rice on here. Okay, and now MATLAB is acting as my frequency generator. I'm going to emit a tone from MATLAB, and we're going to see what happens. Okay, so I'm going to try 500 hertz first. Okay, nothing's happening. Exciting, right? Okay. The next time I'm going to try cranking this up to, how about 700 hertz? Or how about 800 hertz? We'll do 800 hertz. Still nothing. All right, we did 500, we did 800. Now I'm going to bring it down to 700. So in between those two frequencies. And look at that. Isn't that cool? So at 500 it wasn't resonant, at 800 wasn't resonant, but somewhere in between it hit the natural frequency, which was 700 hertz for this thing. And that all has to do with the mass of the object, the shape of the object, and other things. Now, if you want to see what's happening on the sort of the microscopic level, the solution to this problem, I have a movie of that, solving the differential equation. And so if you were a bug standing on this plate, you would see something like this. So I hope all of you still have your 3D glasses. The trip back to RIT to get your stuff was worth it. Just to get the 3D glasses, then it was worth it. Okay, so let's see if this actually does anything interesting. It looks okay. I'll upload this to my courses so you can download the movie yourself and watch it. But this is what's happening on the microscopic level. The thing's moving up and down. There's a piston here. It's moving up and down. You can see that. And that times t is causing it to go higher and higher and higher, which is causing the circle, this valley, for all of the cream of rice to fall into. Okay. So let's try. The neat thing about this is there's not just one resonant frequency. There's several. So let's try another test here. And why don't I show you the 3D movie in the meantime? Here's a 3D movie of the next resonant frequency. I'll play that. You can put your 3D glasses on and watch that while I get this set up. And see where the valleys are being formed. And that's where the cream of rice should settle when we hit this other resonant frequency. For partial differential equations, there's multiple resonant frequencies that you can hit. It is true for the ones that you're solving, though. Ordinary differential equations, there's only one resonant frequency. Okay, this one I believe is 1,892 hertz. So I'm gonna put that in, and I'll put the camera down here so you can see this, and hopefully this works, we'll see. All right, there you go. So there you have it, the Chladni plate experiment. I probably could have just given you a Google link for that, but I don't know if the exact experiment that lines up with the 3D plots exists out there somewhere. I made this nice experiment that lines perfectly up with the solution to these the differential equation that I solved. Okay, I'll turn you back over to the live version of me if that's what's happening right now. I don't know.